So I work for Canonical in the LXD team, as Stefan mentioned. I'm going to do a demo of a feature that is being worked on. It's not yet in master. It will be released at the end of February. But first, let me ask, who has no idea what LXD is? Okay. So there was a presentation before, but it's container management for system containers. That means your container will look like a virtual machine, so to speak. So I'm not going to speak about that. I will assume that you know something about it. So I have three virtual machines here. Each one is running a plain LXD daemon, just fresh from that branch build. As you know, the LXD daemon usually knows only about the containers on the machine it runs on. But I will create a cluster of these three daemons on these three VMs, and they will appear you as one. You can use the regular LXD API transparently against the cluster, and there are also fault tolerance features that I will show. The first thing I need to create the cluster, that can be done with the init command. It asks you if you want to actually create a cluster. Yes, I'll skip some details, but it's just the name of the node, the address. If I'm joining an existing node, no. Press password. I will create a storage pool just with the default values, which will use the fast pool backed by a file. And a network bridge. Alright, this is the bootstrap node, so this is the first node of your cluster. And you can see it's been successfully configured. I can go, and it's empty, so it has no containers. I can go to the second node and run again LXD init. LXD init. And choose the name of the machine, the address. I'm joining an existing cluster now. I have to get the address of this one. It will ask me for the trust password, and if I set the fingerprint, yes. It will warn me that all the data will be lost, and yes, I don't care right now. And asks for storage configuration that has to match the original node, and network configuration as well. So now, if I run a LXD list, I still have no nodes, but if I run LXD cluster list, as well, let me adjust the font here because it sounds too big. So you can see there are now two nodes in the cluster, and I'm going to add another one with the same sequence of commands, essentially. Yes, I set the default underlying cluster, which is oops, sorry. Where did that go? about that. I'm connecting these three machines. Okay, so this was the third one. I just need to get back the address of the first node. Yes, I want to use clustering, the address, design an existing node, the address, the trust password, and thinker node is okay. Yes, yes. And the node now has, the cluster now has three nodes. So I can use the LXD command line transparently across the cluster to spawn nodes, to spawn containers, for example. I can launch an Ubuntu 1604 image called C1, and I can .04. Thanks. And with this new flag / target, I can choose one of the three nodes. For example, I'm on node 3, VM3, VM5 actually. I can target VM3 to download the image and start the container over there. And once the container is started, it will be visible from all clusters, all nodes in the clusters. I can launch another one on VM2, perhaps there's... Oh, 4, yeah, thank you. This is still work in progress. But in the meantime, I can go to the first node, which is the VM3, and if I list the containers, I can see it's there, even if it was created from the first one. C1 already exists, of course. And also from the second node, this is visible, so this is created, so it's still stopped, but it should be started right now. Yes, both are running. And if, for example, I shut down a node, the first node, I shut it down, so it's not there anymore, and I list the containers, I will see that the first container is down. There's an error on C1, and also the list of clusters will show me that this particular node is offline. I can still create a cluster for the nodes that are alive. For example, I can change the configuration of a global cluster value, such as the trust password. Well, let me show that it's there. Yes, there is a trust password. I can unset it, for example. And it's not there anymore. So the first node doesn't know, of course, about this change. And I can even shut down this third node that I just made this modification on, and restart the first one on VM3. And the change will be automatically replicated. So if I run config show, you can see that the trust password is not there. So even if the node is down, when it comes up, the state gets replicated, and I can list containers again. They're still there. The node 2 was up, so it's still running. So the way this is done is by replicating the SQLite write-ahead log using Raft. So the point is that it's very convenient to operate. You don't need a separate fault-tolerant distributed data store. It's all in process. So all you need to run is the LXD process. It will take care of failover and replication of your data. You might ask why. Probably cluster management is considered by some solve the problem since there's Kubernetes, and I was wondering that myself. Probably at the beginning I asked why don't we just create a CRI plugin for Kubernetes and let people drive a single LXD node managed by Kubernetes in a cluster. And yeah, that is possible, but the drawback is that also Kubernetes is a big and difficult beast to drive. So one of the use cases that also Stefan mentioned is systems, applications that were not designed with cloud in mind, applications that are not cloud native and need, in often cases, expect full systems and that can work in system container, but not so well in application container. So we hope that this feature clustering makes it easier to run those workloads without the operational overhead associated with, say, Kubernetes or similar solutions. So that was it. I kept it short. If there are questions or anything, I know I went through rather quickly, so let me know.
Questions? Yes. How failover for containers work?
Failover for containers. So if the node the question is how failover for containers work. If the node you are running on dies, of course your container process dies. In that case, there's nothing you can do. But for example, what you could do is use Ceph as a storage backend for the file systems of your containers. In that case, if your container dies on a node, you can pick another node and start it again. It will be really the same state as it was, because what's written on disk is replicated by Ceph. That is an example, but clustering like LXD clustering by itself does not manage container failover. That's out of band. It gives you some primitives to build on. You have options. One is storage replication with Ceph. There are others, but yeah, this is more or less it.
Thanks. In case of network split and introduce changes in both parts of the cluster, what is the behavior?
So yeah, I'll show you. So as I mentioned very briefly, what we've done is to create a little patch to SQLite, which replicates the SQLite log using Raft, the Raft algorithm. So in case of a split brain, and in order to make a database change, for example, I don't know, an update SQL query, with this machinery, you need to have a quorum of nodes that acknowledge that you wrote that write a log entry. If you don't have a quorum, the operation fails. So in case of split brain, there's just a fail. The trade-off here is that Raft in the cap spectrum, consistency, availability, partitioning, gives you consistency and partitioning, but not availability. In that case, the class is not available anymore, but you won't get inconsistency. So it won't work, but it won't do harm. So you need to have a backup quorum of nodes.
And the actual quorum is recorded as a transaction in the database itself. So if there's a split brain, they all know exactly what the quorum should be, regardless of how many nodes they can see. So they will just hang. Shouldn't go there.
You show that you can config from every node. Is it possible to get a worker node done with LXD?
Can you repeat the question?
To make a worker node that is not in the config map, so it doesn't configure the whole cluster.
I'm not sure I understand the question.
So you have
Three nodes.
3 nodes, and every node can configure the cluster.
Yes.
Is it possible to have a node that is configured by other nodes but not can configure?
Okay. The design is that each node is. So the question is, can you have just one single node, which is your point of reference, and all configuration changes go through that node, and the other nodes, you don't touch them, you don't use them for changing that configuration? The answer is probably no, because the design is that each node is equal in some sense, with some details. Perhaps in the future, what will you be able to do is to set users and permissions to limit, for example, who can do what. But for now, all nodes are equal.
Yeah, so just like that, two things that I mentioned there. One of them is, just want to touch on that. If you've got like a 40 nodes cluster, you only have 3 database nodes. There's no reason for having more than 3 because we get quorum, and otherwise it just gets slower and slower and slower. So we will effectively always make sure you've got 3 just selected ones. That's one thing. So you allow to compute LXD nodes that are not active database nodes, but if you don't change on them, just go through the API and you don't actually see the difference. It's an information detail every day. The other thing that might cover your question somehow is LXD by itself supports copying containers, copying images and all that stuff between LXD nodes, even that are not in a cluster. So you can totally have a non-cluster LXD and a LXD cluster and then copy your containers back and forth. That's perfectly fine. Just like you can have 2 LXD clusters, one for like staging and for production, you can also copy your containers and your images in between the two through the normal LXD network API.
What will happen when I will create a container without the target?
For now, it creates the container on the node you are executing the command on. By the release, it will pick the node with the least number of containers. Yes, so it tries to very simply load balance the workload. So by default, if you don't specify a target, it will pick the node with the least number of containers. This is very simplistic scheduling. This is what we will be doing at the start, but we'll see how it goes. And we can add